So I got the first three parts connected. I just like to show you what they look like. So here they are. So here are the first three parts of the dodecahedron. Now you can see very clearly on here those edges I was talking about. You only need to remove the mill scale from where you're actually welding. If you're doing all this stuff, you're wasting a lot of time. You're going to gouge the surface and you're going to damage it. And there's no need to. You're only welding here. You're not welding here. So why use up your use up your flap wheels? They're not cheap. Use your time efficiently. So here they are. My tacks are on the inside, right over here, so that I have minimal stuff to deal with when I do the weld out on this part. Now, of course, when you get down to the last piece, you're going to have to do that on the outside, but this minimizes the amount of work. Now, in the first video you saw of the dodecahedron, you saw I did have magnets involved. I realized not everybody has magnets. They're not expensive, so I'm going to do this whole build using no magnets. Okay, so this would be the no magnet way. When you got nothing else but a table, your welder, and your hands, pretty much, and your mind. So here's the first three parts. I'm going to weld out how I put the three parts together. This is a really fun way to do it. Well, fun and easy way to do it. This largely comes out of casing, which is the building of boxes from sheet metal. This is kind of an old style way of building it, where I've got the pieces butted up very tightly. This requires that your edges are very carefully sanded and cleaned. So with that, all these are cleaned with acetone as well. So my edges is a very tight fit. I mean, you can't fit a hair between these two. So you have a very tight fitting edges. If there's any space in there, forget about it. It's not going to happen. So I'm checking to make sure my edges are fit up correctly. My points, where the points are going to be, are nice and tight. Because I have to fit another piece here and another piece here. So I'm going to tack these and then fold. And this is why you'll see the relationship with origami and why practicing paper folding is really good for your mind in understanding how to work with sheet metal. It's a very good practice. So you can see that these two parts are now butt welded together. Okay, two little tacks here and here. The tacks do not go all the way through. Very important. If you do that, you're going to weld your surface. Now, of course, a really nice insurance for this process is to work on a large sheet of aluminum, or better yet, if you had a giant sheet of copper, would be great. I do have a sheet of copper I could build on here, but I realize it's not accessible to everyone, so I'm not going to do that. If you just tack carefully, you're not going to weld yourself to the table. The reason why I did this is flat. So wow, why am I building a flat form? Realize you can fold this, okay? I could actually tack weld all 12 pieces flat and then proceed to fold the entire form into the ball. This is called a flat pattern development, okay? So if you look up online what a development is for sheet metal, this is how flat patterns are cut out for things like, especially common for HVAC stuff, like what they call plenums, where you've got different shape, like say a square to round transition, or a square to a pyramidal transition, or a cone. These all have to be cut out of flat sheet metal and then rolled or folded into your form. Classic example is your Chinese food takeout container. You know, if they still make them anymore, the little paper ones, which is a flat piece of paper folded up into a box. We did some of these in class early on. There's a strong relationship with that. Like I told you, you can fold it out of paper, you can fold it out of metal. So watch this. So I'm going to carefully back bend this. Okay? and then check with another part until I arrive at the proper angle I need. Now, like I said, I could make a gauge for this angle, which I know what it is. It's called the dihedral angle. This angle in here is the dihedral of the dodecahedron, and it happens to be 116.56 degrees. If you have a protractor, you set to 116.5, you're close enough. But since I don't have one, I'm just going to bend these until this fits snugly in place, and it looks pretty good. So I know this is correct. So the next step I'm going to do is I'm going to butt up this one, check my sides, find the prettiest side to put on the outside, butt this up here, and now proceed to tack these two forms again, okay? Again, make sure your alignment is good. If your joints are not tight enough, go back there and fix them a little bit, okay? Here we go. Okay, the second one welded onto the center. So now I'm going to carefully bend this one up. Until everything mates up perfectly. Whoop, there we go. So now I have three parts together, and then this one here I can tack weld this one flat here, fold it up, and if everything goes well, these will mate up together, forming, you know, a good half of my form right here. 3 and 3, that's 6. So this is half of the ball right here, already done in what, less than a minute. So you can actually build very, very rapidly, okay, forms if you understand the basics of form. Okay, you understand your geometry, your three-dimensional geometry, and you're very familiar with it, and you see a relationship with folding and metal. You can start to learn the lesson, take the lessons you've learned from folding and apply them to metal, and you can make your work very easy and have fast solutions to some tricky problems. So I'm going to go ahead and start welding this out and figure out which way I want to go. Now if I go here, okay, and I come up like that, what is the likelihood of being able to fit my other part in there? As you can see over here, this space over here and over here are pentagons. There's no way you're going to slip in another pentagon. Okay, it's not going to work. So you don't want to essentially weld yourself into a corner. You have to think ahead. This is called order of operations. Okay, in your mind, like I wrote earlier online, if you can see the form in your head before you do it, you can start to plan your way through the form to successfully construct it without suddenly arriving at a dead end where you're like, uh-oh, I can't put another part in there because I've welded something in place that gets in my way. Whether you can't get your hands in there, or even sometimes you can't get your body in there. I've been in situations like that where suddenly the only access to the interior of something has been welded very small, or you can't get your arm inside. So you got to think carefully. So in this case, I don't want to do that. I want to attach to the nearest point over here. So if this folds up to this point, leaving this wide open, nice and open, so I can put the other part into place. Okay, right there. Boom. So that's what I'm going to do next. I'm going to weld over here. So I'm going to line my parts up. Well, you know what? First thing first, I better tack this together before I forget, because that would not be good to forget that one. Remember, these are butt welds, so I'm going to make sure that it's a corner. Okay, this is an outside corner joint. I want to make sure my edges are as close to lining up as possible. There is a little leeway here, so I'm going to hold that in position and go ahead and tack that. Put a little block here, hold it in place, and here we go. Now, I don't know if you can see on here, okay, but, okay, take a look. Your tacks should be very shiny, okay? Your tacks should be nice and shiny. If your tacks come off looking dark gray, what they call sugared and rough looking, your heat is either way too high or you have oxygen contaminating your gas supply. Either you've got low gas or your tungsten's sticking out way too far, or in some case, your tacks should be very shiny. They should not be dull. Alright, this one's done. Now we're going to put them together. So again, I want to find which side is the correct one. I like that, right here. So I'm going to do these two right here, so that it folds up this way, okay? So I'm going to do that right there. I'm going to arrange them flat, make sure they're flat. Now if they need to be pressed down at all, put something heavy on there that presses them down, okay? Don't be sloppy. So, what have I got? This will work. Okay, now I got the next two tacks down, and now just fold this up right into place, just like that. And you may have to do some correction here. I can see I got to adjust my angles here a little bit, but because the tacks are still flexible to a limited degree, I can kind of goof around with this a little bit in order to get a really nice fit. So I do have a bit of gap in here. You can see that right here there's a little bit of a gap. Now remember, these are flame cut parts, plasma cut parts. They are not machined precisely or laser cut. So there is going to be some cumulative error, okay? If you bundle these up nice and tight, that cumulative error on every single part, that is that few thousandths of an inch where maybe it's cut a little bit small or a little bit big, is going to be expressed in one joint. Now, how do you do that? If it's really big, what you got to do is you have to give each joint a little bit more room, okay? Maybe you want to put a tiny spacer between there. Say a piece of, you could take, say, some really small wire like this, right here, and space it in the joint to give it a little bit of a spread, to spread the error around the form so that when it's all welded up, it becomes invisible, okay? Otherwise, you have a huge gap in there, and it's what we used to call chasing a bubble, where if you have a big cumulative error in a form and you have a big space, you push the space closed, suddenly it'll pop over to the other side, you run over there, and now it comes over here, and it keeps jumping around the shape, and you cannot get rid of it. It'll drive you completely bonkers. So remember that everything we do has some error involved, and you have to be aware of that and be smart about it. So I'm going to fudge this up a little bit and try and arrive at something that I'm happy with here. So I'm going to put this together here, right down there. I'm going to weld this down here, and you can see it, and that should close it up fairly well. It's not a huge gap. It's only about a 1/16 of an inch wide at the bottom, and once it's welded up, it'll be fairly invisible. So I'm not too worried about that. And that's that. So now you have half of the dodecahedron complete right there. You can see. And very nice. Look at that. There's no grinding on the outside, no banging, no nonsense. So whether it's a dodecahedron or it could be even a 20-sided figure, or it could be something like a stellated dodecahedron, which is something I want to build myself, which would be a 60-sided figure. So long as you follow the method and go step by step by step, be careful, be clean, and be aware of what you're doing, it's not such a huge hassle. Okay, but it requires careful attention to what you're doing, and the weld out. Okay, remember this is 1/16 material, so the welding's got to be very careful. We will go into that on the next video.